The Aston Martin Valkyrie is wild. Built from the ground up with aerodynamics in mind, it produces up to 2 tons of downforce and doesn't even have side mirrors because they are too unaerodynamic. But apart from that, the exact aerodynamics of this car is a little secretive, so to find out how the air moves around this car, we simulated it. The flow stays attached very nicely over most of the car, but one thing that really stands out is just how much the flow shoots up at the back. It makes sense because this car was built to generate a lot of downforce, so the wake shooting up indicates that. And in fact, the downforce coefficient of this car came in at 0.54, which is really high for a road car. The velocity over the top is a little high, which is accompanied by a low pressure which reduces the downforce, but it is much better than most cars, and in fact the designers actually reclined the driver so they could reduce the roof curvature and this low pressure zone. Perhaps one weakness is placing this air inlet here because it creates a slight wake that impacts the rear lip. Underneath is where the real magic happens though. There is a front splitter which controls how much air enters the underbody region. From there, the rest of the aero devices can work. Most prominently, there is a major Venturi effect with the central region which is quite unique for a road legal car. As the flow enters, it accelerates and the pressure drops, increasing the downforce. But there are also fins that direct the flow out and around the rear wheels to help reduce the drag. As we get to the back, there is a very fancy diffuser with 2 fins expanding the flow and into the wake, which also increases the downforce while reducing the drag. We can see here that despite all these efforts, there are still wakes coming off the front wheels, and that shows just how hard it is to mitigate them and the subsequent drag associated with them. Looking at the drag, the wake is obviously the main contributor to the drag. Apart from that, the only other region in this plane contributing significantly to the drag is the air inlet. But amazingly, the underbody is doing such a good job of dropping the drag, with some areas registering negative values. Under the splitter plate, there are also negative values, which is a little uncommon. Even the rear diffuser is registering very low drag values, which is impressive, so the designers really went to town when designing this underbody. Looking at the vortices, the wheels and the hubs containing the wheels are creating most of the vortices around the car. The rear is producing most of the vortices overall, which is to be expected considering how streamlined the rest of the car is. In the underbody, 2 large vortices are created behind the front splitter and travel along the entire Venturi region. So what does the drag coefficient come out to be? It comes in at 0.43, which may not seem that good, but considering just how much downforce it is producing, 0.43 is a really good number. Peace out amigos.